All right, hi everyone. My name is Andrew Noviello, and along with my brother Alex, who I assume you can also see on the line, I'm one of the founding members of the National High School Climate Forum, and tonight I'll be helping to moderate the webinar. So first of all, I want to say thank you all for coming to this National High School Climate Forum speaker event, our first one of the 2021 to 2022 school year, Storm Surge, attributing natural disasters to climate change. For those of you who may not know, the National High School Climate Forum is an organization dedicated to fostering an exchange of ideas between student environmental leaders from across the country and educating students at our member schools on climate change and other environmental issues. We currently have roughly 50 schools involved in the forum from more than 20 states around the US, many of which are represented on this webinar tonight. Acting Chief Scientist of the National Oceanic and Atmospheric Administration, most of you probably know that as NOAA, and Dr. Greg Holland, the Emeritus Director of the Capacity Center for Climate and Weather Extremes, joining us all the way from Australia this evening. Per the theme of our event, Mr. McLean and Dr. Holland's presentations will focus on climate change in general, as well as attribution science specifically. Mr. McLean and Dr. Holland will also discuss the roles of their organizations in studying these issues. The event will consist of separate presentations by Mr. McLean, followed by Dr. Holland, and then a joint Q&A session. Feel free to post questions in the chat throughout both presentations. We ask that you post these questions in the private chat, not the public chat, so that they go directly to Alex and I as the hosts without interrupting our presenters. Without further ado, I would like to invite Mr. McLean to the stage to start his presentation. Thank you so much for being willing to speak tonight, Mr. McLean.
Well, it's my pleasure. Thank you, Alex, Andrew, and to all the members of the National High School Climate Forum. Thank you for your interest and your focus. I first have to say it's just astounding to see the level of participation and the level of organization, and it really boosts my spirits to see how the youth of America are really ready to come on in and take our jobs, come on in and start moving forward in your careers. So I congratulate you. I also want to take a moment just to pause and recognize that tomorrow we'll be observing Veterans Day, and I'm sure that many of the students who are out here among us have parents who have chosen to serve in uniform to their nation. And I just want to inspire you all to say thank you to those family members and friends and neighbors, and to just take a moment to thank those people who have chosen to serve their country. We all gain from it, and we all benefit from it, much as we gain and benefit from the science that we're about to speak of here. And I want to commend Dr. Holland and thank him for joining us. I think it's very complimentary the way that Alex and Andrew have asked Dr. Holland and I to outline our presentations. I'm going to spend just a little bit of time telling you a bit about NOAA and how some of our climate measurements have evolved. And then I'm going to defer to Dr. Holland's expertise to be looking more at the intricacies of that. And this is a very positive reflection of how we, NOAA, the National Oceanic and Atmospheric Administration, rely on the academic community, Dr. Holland being a fine representative of that community, in order to gain the best science that we possibly can. And it's quite a collaborative engagement where the government funds much of the science, but the government also funds much of the measuring or observing systems that you'll see in a moment. And then the scientific community can apply their intellect collectively to many of these systems that are sustained and maintained by the government itself. So let's start, if we can, with the first slide, please, gentlemen. Let's pass this one right away here. A little bit of information if you wanted to look at that website to see a little bit more about NOAA. But enough about the guy in that photograph. So here's my beginning. Students, I grew up on the Passaic River in Rutherford, New Jersey. And it was astounding to me that I had to live on a dirty river that I learned people could swim in just a generation before me. And that motivated me greatly in my choice of career ambitions. But here sits what was once one of the most beautiful rivers in the United States, as declared by President Rutherford B. Hayes during the course of his tenure as president. And it's a very different setting today. It's just a reminder of what we humans can do, not just to our local environment, but as we're going to see here clearly, to the entire planet. So we need to be mindful of the choices that we make. Next slide, please. That's me in the delightful, delicious waters of Delaware River leading into Delaware Bay. This is a job that I had inspecting the bridge that many of you may be familiar with if you're East Coasters, and I know we're talking to quite a variety of people around the country, but Route 95, which is a major transportation corridor along the East Coast, found me underneath it inspecting the bridge pilings and the bridge structure during a job that I had working as an industrial diver prior to my career in the government. So I just wanted to point out to you that what you wind up doing in your career may be very different than what you start out doing in your career. And if anyone is interested in diving 30 to 60 feet under the water with absolutely zero visibility because you can't see anything, the water clarity is so terrible, have I got a job for you. But I recommend you stay in school, do the work that you're doing, and come to the advancement and the opportunities that your climate symposium is going to be bringing to you. So next slide, please. All right, so I'm going to give you a quick tour through NOAA. We started in 1970, and I'll tell you a little bit more about that. But today, we're challenged to answer some very basic questions on a daily basis. How many fish are in the sea? If anyone knows, please tell us. But we're challenged to determine the health of the marine environment and to manage the nation's fisheries. We do that through an organization in NOAA called the National Marine Fisheries Service. Next slide, please. So while we're counting those fish, we're also telling you what the weather will be like tomorrow. We do this every day, and we're in your living room, we're on your radio and on your TV, because so much of the information that the meteorologists generate comes from our agency and the National Weather Service, our satellites, our weather radar, and our forecasters who are all over the country providing forecasts and warnings. So what will the weather be like tomorrow? We tell you that through the National Weather Service. You've heard of that, I'm sure. Next slide, please. And the next question. Instead of what's the weather like tomorrow, what will the weather like be 10, 100, 500, 1,000 years from now? This is climate. Weather times time equals climate. And we've been instructed by Congress to do this work, and I'll tell you a little bit more about that in a moment. But that's the third major question that we're challenged to answer on a daily basis in our work at NOAA. And then the last question, please. Are we wise to build on shifting sands? And we're responsible for helping the states, every coastal state, to manage the coastal zone in a consistent manner. You don't want to have excessive development and dredging right next to environmental restoration and preservation. So we look to balance this out throughout the nation across all of the coastal zone. So those are the principal areas that NOAA operates in of fisheries and oceanography, weather, climate, and coasts. Next slide, please. So let me give you a quick history on NOAA. 50 years ago, when NOAA was formed, one of the challenge areas that we were asked to study was what is the interaction between the atmosphere and the ocean? At the close of the Second World War, mid-century, last century, there was a lot of new technology available that allowed us to measure the physical environment of the air, of the ocean, and to notice the weather. And the idea was if we could understand how the air and the sea interact, we'll be better able to understand the weather and the relationship between ocean and atmosphere. So we built an ocean observing system, and you see here a lot of dots on a map of the ocean. Each one of those dots represents one of these yellow buoys that we call Argo floats. And they do the same work that oceanographic research ships have done for years, but they do it in an automated way, and they bring back a lot of information about the physical water column and now increasingly the biological components of the water column. So we built an ocean observing system. We also built, and I'll show you in a minute, the atmospheric observing system, but we built these to understand the air-sea interaction, and we sail a lot of our ships around the world in order to make ocean measurements. What we learned from that is what we today call climate science, that the interaction between the ocean and the atmosphere and the ocean, is what we know today as climate science. We didn't start out with climate scientists discovering this. We started out with physical oceanographers, with atmospheric chemists, with scientists of multiple disciplines working together to understand this. And now today we know that as climate science. We're very proud to recognize that we had the first climate model by Dr. Suki Manabe, who actually this year won the Nobel Prize in physics. He shared it with a colleague from Germany. We also today have what I would argue is probably the best climate model in looking at what the future state will be, and we're running that in an international collaboration that gives us the notions that we have heard about so much this week at COP26 in Glasgow, Scotland, where the Intergovernmental Panel on Climate Change results has been richly discussed, but where the climate treaty under the UN is being discussed and negotiated for updates and action plans for multiple nations. So we've been able to build these observing systems of both the atmosphere and the ocean into models. And you see that represented by this indicator here, this image of the globe with what is called FV3, or finite volume cubed model, which is a model core of what we have today in both our climate and our weather model. So here's the ocean being reduced to models as well as atmospheres. So we switch to the next slide, please. We built an ocean observing system. And if we look here at the atmospheric greenhouse gas observing system, this started here in Mauna Loa, which is on the Big Island in Hawaii. As you can see above the clouds, it's quite an elevation. It actually snows there at times in Hawaii. And we've been occupying that observation site for these same 50 plus years. And it started with an academic inquiry from Dr. Keeling of the Scripps Institute of Oceanography. And Dr. Keeling thought if we start monitoring the atmosphere for parts of CO2, we should see it rise, and we need to track this. So we as a government agency came in behind and have taken up this and several other global greenhouse gas observing sites, but we collect gas from around the world in just about, well, certainly every continent, from the Arctic, Antarctic, in American Samoa, the top of the mountain in Hawaii, across the world, in Africa, many places. And those gas samples are sent back to Boulder, Colorado, not too far from where Dr. Holland's laboratory was, where we analyze that gas. 24 hours a day we do this. And we're watching the planet breathe with the CO2 levels, the methane levels, the greenhouse gas levels, including the likes of CFC, or chlorinated fluorocarbons, which are part of air conditioning escapement, which is damaging to the ozone layer. So we're monitoring all of this. Then we turn that information open to the public, and scientists can use it, analyze it, and see the chemistry and the physical facets of the globe. Next slide, please. So we take these components, these observing systems, ships, planes, scientists working at sea, in the atmosphere, making these collections. We build models, we run them on computers. Here's just a small example of what and where we have our computers located. And then we produce these climate forecasts, these future assessments. Next slide, please. Now you could look at a new product that we have just launched here recently, the climate.gov dashboard, and you might want to jot that down or just take a photographic image of that website. I ask you to enjoy this. Go on there, open it up, and if you're climate interested at all, and I appreciate that you are, you need to be, you can look in here and find so many different references of information that really this is a clearinghouse. We link to many other sources of information, but you could see here in these graphs how we could see the rise in greenhouse gases, ocean heat, the surface temperature of the earth, sea level rising, etc. These are indicators that tell us we're headed for trouble if we stay on the path that we're on. And you could look in climate.gov and see the information from multiple federal agencies. We integrate them there for you. It's a product that NOAA brings forward with great enthusiasm. Take a look at that. You can even see what your climate future is by zip code. So have fun with it. There's a little bit of AI in this as well to help you navigate your way. Next slide, please. So that's part of our job, is to deliver to the public the climate information. And we do this every several years routinely by what is required of us in law, called a national climate assessment. And we produce that along with other federal agencies, but we're responsible for generating it. And it's a responsibility we've risen to for quite some years. You can look those up, the National Climate Assessment. Also, I think you're familiar with the Intergovernmental Panel on Climate Change and the series of reports that international body has been generating. So in terms of addressing the climate, you're going to hear more about this from Dr. Holland, but we're looking at the increased frequency of extreme events. These were forecast 30 years ago. I chuckled at an editorial that was produced by the last administration that didn't have the same understanding of climate science as the current administration does. And the affirmation was being made that the models from 30 plus years ago were not accurate. Well, what was not accurate were those types of assertions, because what we're seeing today was in fact what has been forecast 30 years ago by climate models. So we have opportunities in front of us. We can take what we do today and change it into a greener, or what we're calling a blue economy on the ocean side, but a green for land and blue for the ocean economy that is friendly, that is a circular economy. We don't utilize resources and then cast out the waste. We look at the totality of our production. If there are resources we need to utilize, we want to make sure that they are, number one, sustainable, and number two, that any byproducts generated from that economic pathway are usable themselves rather than waste that needs to be compressed, compiled, and then disposed of at some risk or harm to the environment. We're looking at challenges now like coastal resilience, where more than half the country lives on or near the coast, and the impact to the coast no less than the impact to the heartland of America. But the capital that's been invested on the coasts where people are choosing to move, concentrated density of damaged sites when a storm comes ashore or when we see sea level rising and inundating, which is starting to happen more frequently. Water availability with droughts, notion of greenhouse gas control. Some new discussion that I hope you're focused on as young people is equity. Should the zip code and the wealth of your zip code determine how much service you get by way of weather forecasts or care and concern from the people who are your stewards and your guides, your government? And we want to make sure that we're delivering equitable services to both the wealthy and the not wealthy in an equal way. Okay, next slide, please. One of the areas that we're working in as an example of that are urban heat islands. And this is NOAA working with university academics and colleagues to go into cities and measure what the areas of heat differential might be, where there are portions of these large cities or these urban areas that are more impacted by heat because there's no shade, no green trees, there's blacktop or macadam that just absorbs heat and concentrates the heat rather than a lighter color that would dissipate or reflect heat. How we build determines how well and how healthy our communities are. And unfortunately, the equity mindedness shows us that the urban areas where usually the economy is not rich and thriving for the people who live there, right? All of us go and retire to the suburbs after the workday, but the people who live in the cities are dealing with much more heat stress than people who live in the suburbs and have more open areas, green grass and trees, and are not concentrated in concrete caverns with very dark surfaces that absorb radiation and absorb sunlight and heat. Next slide, please. Here are some of the students, and here's an opportunity for you to recognize that these urban heat mapping campaigns are often done with student assistance. And I'd be happy to follow up with Alex and Andrew in order to explain to you how you might be interested in joining this and doing this. But there's a lot of activity that citizen science can be contributing to help us understand and map the phenomenon that we're dealing with here today, the consequences of climate change, and the indicators of how that climate is changing. So next slide, please. So a summation here shows you that NOAA starts with, as I offered, the information collection that you see on the far left through satellites that we've built, weather radar, buoys, ships, aircraft. There are wonderful career opportunities, by the way, in doing this. And I've had what I consider to be a thrilling career in NOAA. I've been doing this for 40 years, and I began in the uniform side of NOAA. We have a service that used to be part of the Navy. It's called the NOAA Commissioned Corps. And we have naval ranks just the same as Navy and Coast Guard do. I retired as a captain and then came into the job that I have now. But operating these systems that collect this information to then process and store this information, make it freely available to the research and modeling community, both modelers inside of NOAA and academic modelers, including the colleagues that Dr. Holland works with out at out at NCAR, the National Center for Atmospheric Research, and other places. And then we work to take that information and turn it into a usable product that the public can look at. What is your sea level rise or inundation going to be in the future? What is the frequency of storms and extreme weather that you're going to realize in what zip code in the future? And we're working to provide the greatest fidelity of that information. But then we, inside of NOAA, have the ability to take this information and through dissemination, bring it to the public by making our information available to commercial weather forecasters and broadcasters, but also producing it so that you, the citizen, can get it directly on your cell phone. Then we also have tools that are helping cities plan for climate futures and helping, as you might have seen, much of the discussion in the national news about the infrastructure bill, bridges, sewer pipes, drainage, the tools that we need, railroad tracks and renewal. Are we building for what we experienced yesterday in the past 50 to 100 years? Or are we smart enough to build for what we're going to get in the future, where dry areas will get drier, wet areas will get wetter, and the extremes that we're going to be facing? So that's where the community-based application of our programs is very important. Once again, we, the government, work side by side with the university community in order to bring this information into the public through a series of programs that we have around the country. Next slide, please. All right, this one I love because I know that one of the features of Dr. Holland's career is looking at severe storms, storm frequency, and many aspects in his career. of looking at climate impacts and where and how we could measure them. But I don't know if you saw this recently, but we were able to put this device called a sail drone into a Category 4 hurricane, Hurricane Sam, and it was able to make measurements right at that intersection of the ocean and the air. And that's where all the heat is transferred into the atmosphere from the ocean that helps to fuel a hurricane. So this was our nirvana. This was getting a vehicle and a device to make measurements right in the heart of the hurricane, right at that eye wall. 140-mile-an-hour winds, 50-foot waves. During my seafaring career, I've not seen 140-mile-an-hour winds, thankfully. I have seen 50-foot waves. You do not want to see 50-foot waves. But it was remarkable to get this autonomous, uncrewed device into that hurricane. And we'll be doing more of that to bring back more measurements of the heart, the heat, and the tempo of the hurricane so we could bring better forecasts to the public. Next slide, please. There's also a thrill for you I'd want to talk about just very briefly in oceans, and it's the Ocean Exploration Program. 20 years ago, I had the opportunity to start this program as the first director. It has thrilled me ever since. This is your basic, imagine your parents' SUV on a cable tether. That's about the size of it. It's about the weight of it. And this device goes to the bottom of the sea down about 6,000 meters deep and looks at 98% of the coverage of the ocean with that depth capability. So exploring the ocean is really an important opportunity because we don't know enough about the ocean today. And because of us humans and our impact on it, it's changing more rapidly than we can establish a baseline. There's plenty of parts of the ocean to discover and that no human eye has ever seen before. Career opportunities for you indeed. Next slide, please. All right, and let's talk about the power and the strength of students. This is a team from California that won an X Prize competition. The prize was twofold. The first group was a group of PhD scientists and journeyman ocean mappers. The second group, for a second phase of the contest, was competing with PhD and academics and professional engineers. And this group of high school and junior high school students won. And what they were doing was chasing a source with autonomous equipment in the water column. Their device had to sense a source and find the origin of the source. The other component of the contest was to map an area with greatest accuracy with an uncrewed or autonomous system. And it just thrilled me to realize the talent and the power of intellect in young people, junior high school and high school students. They won $1 million. So I celebrate them and I celebrate you, and I offer that opportunity in your career ambition. So I think we close here, and the last slide should put an end to that. Nope, I'm sorry, one more thing. When you look at these new developments that we have of alternative energy and a different way of managing our ocean areas, there are wonderful career opportunities for you. And if you're an adventurer that wants to dive 60 feet deep in zero visibility, that's one thing. You want to climb to the top of the tower and make sure that America has power, that's another thing. But there's a lot out there for you, whether you want to be in a laboratory environment, communicating with the public. The door is wide open and the career opportunities in front of you are amazing, especially as we try to address the climate crisis that we're under. I think now, last slide, there we go. And I will defer questions to the conclusion of Dr. Holland's presentation, but this is a shot during my relative youth, probably about 30 years ago, 25, 30 years ago, when I was operating one of our NOAA research vessels out on George's Bank. So thank you very much for your attention, and I defer the floor back to our two hosts. Thank you.
Yes, thank you so much, Mr. McLean. That was super interesting. I learned a lot, and I know all the students and faculty in attendance did too. As a reminder to our audience, feel free to continue posting questions in the chat. We've gotten quite a few so far, more than we'll ever have time to get to. But if your question hasn't been posed before, we'll definitely make sure to get it in. So keep those questions coming for both of our speakers. I'd now like to invite Dr. Holland to the stage to continue with more specifics on weather extremes and attribution science specifically. Again, Dr. Holland is joining us from Australia. So everyone, let's give him a warm welcome to the Climate Forum. Dr. Holland, you have the floor. Let me get your thing set up now, your presentation. There you go.
Thanks, Alex. And I'm assuming you can hear me okay? Okay, so we're
Yep.
on the
Yep.
first slide. It's just the title and things like that. But while we're on this slide, I'd like to just refer back to Craig, and I think it's important to note that NOAA hasn't always had the most congenial of politicians that are trying to make them do things. And over the period of the past couple of decades, when I've been interacting with NOAA, they've been absolutely honest in the science that they present, and those climate summaries that they put out every year for the US and every few years for the world at large are essential reading to someone like me. So when you actually go out, of those who become scientists, do remember that the thing you owe, the only group you owe allegiance to is science. You need to be absolutely honest in your opinions. Don't be afraid to make assumptions, but be honest in your opinions. And at the end of the day, that's what makes a truly great scientist. So let me move on. Responsive extremes to climate change. Next slide. Now I'm assuming it went over to extreme weather events.
Went over to extreme
Okay,
weather
so
events.
basically this is just a list of a few extreme weather events. Craig has also noted a few. And you'll notice that they're all pretty high and they're pretty extreme, and some of them are things we've never heard before. For example, just a few weeks ago, it rained for the first time at the peak of Greenland ice sheet. That's on ice at 10,000 feet. And then there's European flooding, there's Death Valley with its high temperature, there's a whole bunch of other ones that I'm going to show. So what's happening? Well, I think if we go to the next slide, what's happening is, of course, the world is hot and it's getting hotter. And how that impacts us is actually somewhat counterintuitively through extremes. And what I'm going to show you in the first part of this talk is how extremes must respond quite strongly to any small change in the overall distribution. And then we'll move on to a few examples of typical or extremes as we go through. Next slide. So here we have a distribution. We've got two distributions. Along the bottom line is the bottom axis is the anomaly in some unit. On the vertical axis is probability, or if you like, the frequency of events. They're both the same thing. And the white one is a normal distribution, which has been shifted to the right for the red one, along with a little bit of flattening. And let's just sort of look at what that little shift did. Firstly, you'll notice that the most frequent occurrences were around the 0, which is what you'd expect. But in the new one, the most frequent occurrences are around 1. So next part, Alex, please. Did it go up?
Yep. It's on Australian heat waves now.
Yeah, just making sure that it's happening as it should. Okay. So you'll see that in the white one, events that were happening 33% of the time are now happening 50% of the time. Next one. Events that would have happened very, very rarely indeed are now happening 20% of the time. Next one. And events which would have been completely unheard of in the past are now happening every 5% or thereabouts time, about 5% of the time. Well, that's a little typical example, but if you hit the next button, you'll see that it's not actually made up. I've just shown you the distributions of annual global temperature anomaly, with the white one being what it was like back in the 51 through to 1980 period, and the red one being what it was like back through 2004 to 2014 period. And if I was to put up the current one, it would even be further to the right. So this is not made up information. This is the way all extremes react to the change in a distribution. Craig mentioned earlier that we knew, 30, even 40, 50 years ago, we could make very good statements about what was likely to happen. And we were able to say things like this because we understood the physics of it. And the physics are what I've just showed you. Now, I could have made that rainfall. I could have made it heat waves. I could have made it flooding from sea level rise. All of the same comments apply. So next slide. Here's just one example from my part of the world. Along the bottom is time. On the vertical axis is the number of days where the mean temperatures were in the warmest 1% of records. So and this is an annual thing, so you'd expect that to happen maybe once or twice a year, or maybe once every few years. Well, that's what it used to be back in the 1910s through the 1930s and 40s, and then it started going up, and it's been going up exponentially to the stage that in 2020, we actually had over 40 days where the 1% occurrence occurred. That's very similar to what I just showed you before on the previous slide. It's a very much amplified response. Next slide. I'm sure you've all been aware of the recent experiences over in Canada and in California. Let's just take the Canadian one as an example. On the June the 30th this year, that's what the temperature anomaly in Western Canada was. And the dark red is greater than 15 degrees Fahrenheit in this case that they experienced. And indeed, there were some stations within that red that actually experienced 15 degrees above the previous all-time record. Now, when I first got into this game, I understood a lot of these things, but I have to tell you, there is not a chance in hell I would have told you I'd ever see something like that in my lifetime. They will see it again because we've seen similar things in other parts of Siberia, and even Alaska has actually experienced not dissimilar things in the near past. Let's go to the next slide and consider California. Well, California is burning. There's been fires, and the reason for that is partly because there's been a very strong increase in droughts. The top graph shows you the timeline, and then a drought severity index, which is the total area over which drought was at a certain severity, if you like. It's just giving you an idea. And you see back in the early 2000s, yes, they had a period like that, and then it sort of dropped off, and then it came back stronger. Then it came back stronger again, and then it came back up in the early 2020s to stronger again. On the bottom line is the percentage of area in California that was experiencing various stages of drought. And let's just look at the dark red. Exceptional means that it hasn't happened before. Basically, it hasn't happened before. Back in the period up to 2010, you never saw any dark red. In the period since 2010, it is now becoming a regular event. The reason for these sorts of things are that whenever the rainfall stops, the very dry and very hot condition, or the hotter conditions that are being experienced with climate change, dry things out faster. So you go into droughts earlier and you stay in droughts longer and they're more intense. But if we actually dry things out, and if we're able to evaporate more water, that means that over the oceans and in other parts, we've actually put more moisture into the air as well. So when we flip over, the opposite happens. Next slide. We get more flooding. And this is the storm, the large storm that came through just a week or two ago, that actually affected, the storm itself hit northern USA and Canada, but the effect as far as rainfall is concerned was down in California. And you see those long white bands. They're things called atmospheric rivers. where moisture has been picked up in the deep tropics, and then because the cyclone's there, it's been brought up around the cyclone and into the mountain ranges along the California backbone. It gets lifted up there and it rains. And it has been raining. So you go in just a very short period of time from a drought to massive floods. It does terrible damage to the environment, because that then leads to landslides and various other impacts in addition to people just simply being disrupted. Now, I'll just make another comment here, and that is, if we go to the next bit, California actually thought about these things some time ago. At about 12 to 15 years ago, when I was working at NCAR, we interacted with the Californian authorities when they did a thing called an arc storm, which was to look at the worst case storm, including climate change or some estimate of climate change that could impact California. And so they'd already started more than a decade ago to change their procedures, to actually put in protections and things like that to help them weather that. And that's all credit to them, because they've paid the cost of that storm, of making that storm program back in spades just in this one event. Next slide. The last case I'll show is tropical cyclone intensity distributions. And here is a diagram from a paper that I published. It basically shows you a series of lines. The red dashed line is what the intensity distribution looked like in 65 to 74. The dotted line is what the intensity distribution in recent times. And you can see, if you look at the category 4, it's gone up every year in that period, steadily up. And if you look at the category 0 to 1, 0 means tropical storms, or even 2, it's gone basically down in most of those years. Well, this is the same sort of thing that I was showing you before, but now it's not so much the storm intensity distribution that we're looking at. We're looking at the distribution of rapid intensification and the distribution of time spent over warmer oceans, both of which have gone up. And that's why you've got that sort of piling up of storms, if you like, at the intense end. They're able to get to greater intensity quicker because they're either rapidly intensifying or they're staying over warmer oceans for a longer period. Now, there's a fairly large element, there's a significant element of observing system change in here. I also must hasten to add, we counted for that in the paper, but there's now been several papers which have actually looked at these intensity changes and found quite similar results. So this is a real result. Next slide. And just to emphasize that very briefly, whereas back, the ACCI is a climate change index. It's basically degrees C warming of the globe. And the proportion up the side, we show that back a couple of decades ago, a few decades ago, the percentage of storms in category 1 and 2 were around 60%. The percentage of storms in category 4 and 5 are about 20%. The category 4 sides now are around 40%, and 1, 2s have dropped down to about 50% or a little bit less. So when you look at tropical cyclones coming into the US coast or anywhere else in the world, and you say, well, is there a climate change in this particular storm? It's very difficult to quantify that without very sophisticated models and a lot of time to think about it. But what you can say is there is pretty well zero doubt that you are going to experience more such events as a result of climate change. Let's pick one. There was some interest expressed in Hurricane Ida, so let's take Ida. It's from fairly recent memory. And I'll just get Alex, if you could just click on the tracker shown there. If you could click on the track for me, please.
I'm going to actually just share the YouTube video directly. 1 second.
Okay. Well,
Here we go.
that makes it a bit... Okay, just give me a second now to catch up with you.
I should be sharing screen now with the YouTube video.
Yeah, I've just got to get my talk off and right, if you could press the go button, please. Okay, now stop. Just there. This is when Ida was just a tropical low. It had barely even been noticed. It was only just starting to be talked about in the warnings and such. And that country to the south and southeast of that L is Venezuela. Well, even at this stage, Venezuela got severe rain, very heavy rain, severe flooding, and 20 people were killed. Now, was there climate change impact there? The answer is, let's think about it. We expect that there's going to be more heavy rain because I've already shown you why. So ask the question the other way around. Was there no climate impact here? And the answer is that would be a highly unlikely situation. So yes, there was a climate change component to that flooding is the logical answer. But how much? Well, if you wait around for another 6 months or a year, I'm sure that you'll find there's lots of published papers coming out that's actually describing what that impact was, because they can do that with the current generation of computer models such as Craig mentioned. Move it on. So it came across and then started heading northwards. No surprises here. It's just following a typical tropical cyclone track. It's gone to a tropical depression. It's now a tropical storm. It is now a category class 1. Stop. Just, yeah, that's good. So when it came across Cuba, it caused a fair bit of damage. There was strong winds and some very heavy rainfall and a lot of damage to both shrubbery and some damage to buildings and things like that, but nothing particularly special there from the point of view of climate change, because as you well know, Cuba gets hit regularly and they would not have been too concerned about that as a storm. Let's go on. It moves out across the Gulf of Mexico and stop there. Okay, that's a category 2 and it's approaching Louisiana. Now watch the next few slides, the next little bit once we get going, and tell me if you can see a number 3 come up. Next. Stop. You're better than me if you could see the number 3 came up. And why was that? Because it went through a very rapid intensification period. It went from a category 2 to a category 4 in almost no time at all. That is one of the things that we do expect to occur more frequently with climate change. Keep going. It then came into Louisiana, stop, and was the second most damaging storm since Hurricane Katrina, which was also another category 4, maybe category 3 storm that actually was decaying, having done its rapid intensification well out over the Gulf, and was actually weakening when it came ashore. But the point of view from climate change is here, that sort of frequency of category 4s is again what is expected from climate change. So if you live down in those areas, and that includes Florida, all the way across to Brownsville, then you can expect there to be a higher frequency in the future than has been experienced in the past. Keep going. As it goes up over the Midwest, it does the usual, decays over land and keeps going, and it's now down to a storm, and now it's a depression. Just stop it about there. Okay, in this particular phase of it, there were quite a lot of tornadoes. Now, I don't know if tornadoes around tropical cyclones have increased due to climate change or not, and I don't think anyone does. But I can tell you, when I was your age, it was a really rare event to see a tornado in a tropical cyclone. Nowadays, it's a much more common event. There are two possibilities. One, something's changed in the atmosphere that has enabled or forced this to happen. Or the other one, which is actually equally likely, is that people just happen to see tornadoes more because there's a heck of a lot more people out there. So we don't know, but there's a possibility there. Keep going and stop it when you get up to Philadelphia. There's good. Okay, so now we're over Philadelphia and it's a extra tropical storm, which means it's lost its tropical characteristics, but that doesn't mean it's a very weak storm. It can't still do damage. And in this particular case, look at the area out to the east and southeast of that X. That area is an area of moisture, and because of climate change and the oceans being warmer and the air-sea interaction that Craig talked about, that air has more moisture, and the cyclone is sucking that air up and bringing it around to the northern side of it, up into the Appalachian Ranges, and you get severe flooding. And there was an awful lot of damage and a quite remarkably large loss of life as a result of that. Was it due to climate change? The answer is, ask the question again. Was it not? Would you expect no result due to climate change? And the answer is no. So it was probably due to climate change, and we'll have to wait for the studies to actually be able to look at the amount. But that's the sort of things I want you to be asking yourselves as we go on away from these talks, and then you're looking at these sorts of events. You can finish it off there. Thanks, Alex, and go over to the next slide. Go back to the talk. Just waiting for it to come up. Right, so next slide. So what can we do about it? Well, let me ask the question first. Let me make the point first. I mean, it's obvious that the world is now hotter than it has been in our lifetime, but it is actually hotter than it has been in any time as human beings, since human beings evolved as a species. This is unheard of in our existence, all our ancestors and everyone else. Make another point, and that is 2/3 of global carbon emissions are attributable to the decisions we make. It's very easy to blame the politicians and everyone else, but you need to clean your own act first. Get yourself thinking seriously about not emitting as much. Talk to your family about it. Talk to your school about it. Talk to your local shire about it or your council. And then, if the politicians do nothing, at least you're doing something and you will make a big difference. And just to emphasize this point, according to a new Chinese satellite that was just launched a year or two ago, we're now emitting CO2 at an annual rate which is 12 times the mass of all humans. These are not small amounts. It's easy to sort of talk about parts per billion and things like that. There is an awful lot of junk going into the atmosphere. Next slide. So just to finish up, I put it to you that the evidence is in plain sight. The impacts are already occurring. The decision is up to us and us alone, and we have two decisions to make. Do we buy that lovely house with a beautiful stream running through the back and do nothing? Or if we already own that house with a lovely stream running through the back, do we do nothing? Or in both cases, do we actually start to adapt as well as actually try and stop that event happening? So in this case, the adaptation is a rowboat on the roof. Hey, it ain't great, but it's better than nothing. Thank you very much.
Dr. Holland, that was a great presentation. I found it fascinating, and I know a lot of the students did too. Both Mr. McLean, Dr. Holland, you both can, if you're able to turn your videos on. We'll start the Q&A session now. So again, if anyone wants to do just put last-minute questions in the chat, that would be great, but we have quite a few questions to work through, so we can get started here. First question.
I can start us off, Alex?
Yeah, go ahead, Andrew.
So I have the
the questions we collected before the event right here in front of me. So I was wondering, this is one that came up a couple times. What got you both interested in climate change research and study, and brought you into your current career field?
Dr. Holland.
Okay, well, I grew up as a dancer, actually, and then I went off to university, as you do, and I got very interested in maths and physics. And I had no idea I was going to become a meteorologist, and I was sick of being broke at school, so I applied to the Bureau of Meteorology for a cadetship, which means they were silly enough to pay my fees and actually pay for me to go to university for the last year or two. So I joined up. Once I joined up, I thought, hey, this is pretty good, and I've been there ever since.
Dr. Holland, I wasn't a dancer, I was a drummer. And I spent some time in dark alleys in New York City moving drum sets around. And I was also working diving at that point in time. And I realized time to get back to science, which is what my undergraduate was in. And I found my way into NOAA. And NOAA had a program that trained me to pilot ships. I had worked small boats and the like before, but my God, to be on a research vessel. When I was 11 years old, my dream in watching Jacques Cousteau was to be a deckhand on a research vessel. I never thought that I would one day be the captain of a research vessel and then go on to have the types of opportunities that I have and the job that I have today in what I consider to be a very marvelous agency. And I want to thank Dr. Holland for his comments regarding NOAA and our integrity. We do believe strongly in the integrity of our science, and I appreciate that very much. So don't be bound by what you think you're going to do now, as you see from both of us, but explore that opportunity intellectually and be adventurous.
That's great. That's great. Another question that I thought was interesting and pretty applicable. I guess I'll send this to you, Dr. Holland. Do you think the effects on natural disasters of climate change are reversible? So if we do limit the warming to 1.5 degree, 2 degree benchmarks, do you think the natural disasters will go back to normal as well?
The answer is yes, but it takes a long time. The junk we put into the air now, by the time that actually all that effect works its way through the entire atmosphere and ocean system, remember, anything that goes into and through the ocean takes a long time. And also the CO2 that is in the air is going to be there for a long time, like decades. It'll be there longer than you kids have been alive. So yes, it will come down, but it'll come down gradually. The urgent thing right now is that if we don't stop emitting and we get up above 2 degrees or 3 degrees or 4 degrees, then we're in deep trouble. You reckon it's bad now, it's going to be very bad then. And I mean that because those of us that are actually thought this through, and the experts in the social sciences that actually look at these, it's pretty close to a uniform view that if we get to 4 degrees C, civilization as we understand it will actually will disappear. You're already seeing it in the people that are actually caught up in trying to get into Europe and trying to emigrate because they've run out of food. If you're hungry, you'll go anywhere you can get. And that's what's going to start happening a lot more.
Good to hear, though, that it is possible. Reversing the effects are possible at some point. Question for you now, Mr. McLean. I got a lot of these questions in the registration. A lot of people were interested. They don't think that many other people attribute some of these weather extremes to climate change. How do you think that awareness can be spread about the relationship? And maybe what role can NOAA play in that? What role does NOAA play in climate awareness in general as well?
We do spend quite a bit of time and money trying to provide tools so that people could be self-educating, try and make it plain and easily understood, like that climate.gov site that I showed you. And while we compile that, that's contributed by many different elements and entities, universities, and mostly government agencies. Most of it's NOAA data because that's our assigned responsibility. I think the reason why there's confusion is that there are components of society who have found it in their financial interest to create uncertainty and doubt in the science. They can't disprove the science because the science has for a long time been reinforced, growing, and proven. But if you are in a business model, just by analogy, think of cigarette manufacturers. You're invested in a business model that you don't want to see change. And you have stranded assets. That's the term for infrastructure you've invested in that you're going to have to change if society changes the direction of the CO2 that we're pumping into the atmosphere. And there are some very skilled authors and historians who have looked into this and really have characterized that there has been a financial incentive for some to basically plant seeds of doubt in the science. When you look at the science, there is no doubt in the science. This year's report from the Intergovernmental Panel on Climate Change made that abundantly clear. But it depends on what noise you're listening to. For the past 4 years, we had a lot of noise coming out of the elected federal government that was dismissing climate change, and that was politically motivated. Here now, you're hearing an administration that's adhering to the science and letting the scientists speak for themselves. We had difficulty as scientists speaking for ourselves in the past administration, and those matters have been adjudicated and proven. So it's important for young people and advocates and people who are thinking progressively of any age. Look at the source of information you're dealing with, understand its validity, and then establish a value precept to how strong that information is. And if someone's got another agenda in mind, you look a little bit harder and you'd be pretty able to see that. But the climate science has been well understood, well proven for a long time. It's just a question of components in society that are putting a cross message in there. Much like, I don't want to be political, friends, but do we really believe that the election was not appropriately settled after everything we've gone through? There's a lot of disinformation and no editors on the internet. So you've got to be really careful what you choose to listen to. There are editors in the published commercial press, and you can see the quality of their product. I'm sorry to get off track there, but I feel very strongly about this. Thank you.
We're trying to alternate between you both. For Dr. Holland now, I thought this question was interesting too. You hear climate change affecting different regions of the world in pretty significantly different ways. Is climate change going to affect extreme weather patterns differently in different parts of the world, or
the answer is absolutely yes. Yes, absolutely yes. Think of it this way. When you look at the daily television forecast, the weather in the globe is different weather everywhere, right?
Yeah.
Well, okay, climate change affects different areas differently. But there are some areas where it affects things consistently differently. For example, areas like Siberia and Canada, the near Arctic sort of areas are warming up much faster than the areas further south, and there's good scientific reasons for that I won't go into. Then there are things like, let's just say that the El Nino cycle changes, and I'm not saying it will, we don't know properly, but let's say it will, then that would change the hurricanes hitting the United States. It may make them much more frequent, or it may make them much less frequent. But the point is that once those sorts of things start to kick in, then you get those other sort of events. So the answer is yes, it is consistently worse or bigger impacts in some areas. Some areas have not so much impacts at present. The last one I'll mention there is that if you're over the land, it's going to be universally worse than if you're over the ocean. And if you're in a forested area, it's going to be universally better than if you're in a non-forested area. For example, a lot of the southern parts of the United States will become essentially unlivable at, say, 3 degrees or thereabouts, because the humidity plus temperature combined will mean that you actually won't be able to go outside. You'll die because you've got a fire inside you called metabolism, and the only way you can keep it under control is by sweating. If you can't sweat because it's 100% humidity, you can't live. Those are the sorts of things that will affect people.
That's a sobering fact, Dr. Holland. Back to you, Mr. McLean. I think there was quite a few questions that came in about some of the systems you were talking about that NOAA facilitates, like the ocean observation systems and some of the climate models. And Dr. Holland, you might be able to talk to discuss this point too. But how do you calculate storm surge, flood heights, the effects of these natural disasters with some of those systems, Mr. McLean?
Well, the bare measurement of storm surge is definitional. There's an average height of the ocean. There's a high tide, low tide, mean lower low. It gets with engineering precision, it gets very technical. But we measure that. We have tide gauges around the country and actually around the world in a unified network that measure the mean sea level. So we can tell when it's increasing, and we have measured that. We have seen that there is sea level rise attributable to wind patterns, but also to the warming of the ocean. And oddly enough, though it may not be conventionally understood in all high school chemistry laboratories, you warm that water, it will expand. And that is happening in the ocean as well. So we also have in the east coast of the United States a degree of subsidence where the fluidity of the Earth's crust is actually not completely stable over geologic time, and there is some subsidence. So you put those two together, of the wind and the climate impacts, a warming ocean, et cetera, sea level is rising. We measure that daily, but we can't tell you that today sea level rose this much. You're watching a high and low tide constantly oscillate. But when that oscillation starts going up, you start to see where the average is now increasing. As we do that over time, we have a very good measurement of that. Add the storms that Dr. Holland was talking about, the severity and the increased intensity, you're pushing more water onto land. So you're not just talking about a mean sea level rising, you're also talking about inundation at those trends exceeding what the norm is, and with more extreme storms, that insult or invasion of the ocean onto the landmass is going to be even higher. Think of Hurricane Sandy for the East Coasters, or think of Houston with not just the storm surge coming in, but certainly 55 inches of rain over the city of Houston a couple of years ago. That was almost unthinkable. People were asking the question, did you misplace a decimal system? Is that 5.5 inches? No, that's 55 inches. And the forecast was proven. It came through. So there are these extremes that Dr. Holland was talking about that you put on top of storm surge, and they really create more of a Mad Max scenario than what our normal historic weather has been showing us. The new normal is upon us, and we don't know exactly where it ends.
So, Andrew, do you think I think we'll probably have time for one more question.
Well, let's ask Dr. Holland, Mr. McLean, are you guys okay for staying on for one more question?
I'm happy to stay on, no problem.
Perfect.
All right, sounds good. So, Dr. Holland, to direct it to you again, going back and forth here, I know Mr. McLean talked a lot about student opportunities in regards to NOAA, but could you tell us a little bit about the organization that you're the Emeritus Director of, the Capacity Center for Climate and Weather Extremes, a little bit about NCAR, the National Center for Atmospheric Research, and maybe some ways for students to educate themselves about opportunities related to those two organizations and about attribution science in general?
Yeah, just to sort of add, I actually came to NCAR as a director of one of the science laboratories, and when I decided to step down from that, you can only stay at those level jobs for so long, and then you get a bit tired. So I then set up C3WE, the Capacity Centre, sort of as a fun thing to do. And that was set up specifically to be able to advise industry, the general public, and anyone else on what was happening, but also to actually do basic research would help with that advice. So that was what it was there for. As far as NCAR itself is concerned, there are enormous opportunities for people at your level, for kids all the way down to primary school for that matter. For example, we have an organisation which actually brings students in. You have to apply and you've got to pass various tests and things like that, but brings people in, and this is people across all parts of society, both unrepresented as well as the white Caucasians and such. And they actually get to interact with the real top-level scientists. I've had several that have come in and they've worked with me sitting in the office next door. And they get a chance to work with you, and they do a project and things like that. They get taught how science works. They get taken up to the computer and show how all that puts together and everything like that. And then on top of that, we actually have scholarships, if you like, which will actually pay for younger people to actually work, not necessarily at NCAR. It could be in a university. It could be in NOAA, for that matter. We've paid for students to go to NOAA and do a year or two there to actually decide if they like it, if you like. And it gives you, but what it does do, it gives you a chance to network. And believe you me, there is nothing like knowing a few of the better scientists to be able to actually work out how it really works, because they tend to be sort of brutally honest with everything.
Question. What would be the number one thing, and this is to both of you, you each can answer, what would be the number one thing you hope to see in the next 5-10 years to help mitigate this issue? Number one thing. Dr. Holland.
Craig, you go first.
Thank you, Dr. Holland. I appreciate the courtesy. I would love to see us get off a carbon-centric economy where we're polluting the atmosphere with carbon dioxide. We have to do this. We have to find a pathway, and we need to do it urgently.
Dr. Holland?
I have to say exactly the same thing with one qualification, and that is that it's going to be up to you kids. I can say kids about young adults now because I'm old enough to say you're all still kids. It's going to be up to you kids to do something about it, because to be quite honest, the older generation are not really proceeding fast enough. And the school children around the world that have actually been up there and fighting for this are making a difference. And it's going to be up to you guys to make the big differences. So don't be afraid to tell your politicians to get involved in local things. Heck, go out and demonstrate. We demonstrated against the Vietnam War, and it was nowhere near as important as this stuff is. So get out and do something.
If you guys wouldn't mind answering. Do you both think we can realistically mitigate the global warming to some of the thresholds that have been thrown out through various agreements, like the Paris Climate Agreement at 2 degrees Celsius, etc.? Do you think it's realistic to mitigate climate change to that level? And if so, how should we do that? Obviously, you've addressed some of those already.
Dr. Holland, I'll defer to you on this one. I certainly have an answer to share, but you go ahead, please.
Okay, well, the answer is yes. It's not unrealistic. It's possible. I will say that it depends on how much you're talking about. I don't think there is a chance in hell we're going to stay within 1.5 degrees, despite all of the good attempts. You've got countries like China and India that aren't going to slow down for a while yet. And remember, we were in their position 100 years ago, and we were burning stuff as fast as we could. So you can see some of the justification. I think, given the momentum it is now moving in the Western world, and which India is at least bought into it, a partly thing, and other countries like Indonesia and that are bought into big time, that we can keep it down below 2.5 degrees C, and that would be terrific. Indeed, I think we probably will keep it down below 2.5 degrees C.
I'll double down on Dr. Holland's comments. I think there is a compelling self-interest that humans have, particularly when you start getting to governments and making choices for the public and finding ways to facilitate the change from a carbon-based economy to other sources of energy. But as Dr. Holland says, you start looking at a rising middle class in developing countries, their power needs are going to go up per person the way ours did when we were developing. So it's a very compelling problem with the size of the world population and where these densities of population are coming out of a developing economy and more into the middle class. Okay, so that's the problem statement. If we look over in Glasgow, what's going on now in the consultation of the parties, or COP26 from the climate convention, the discussion now is that if we all as nations fulfill our obligations that we're stating, of course, we all have to go home and then implement those obligations. But if we can do that, as Dr. Holland says, we're hovering around 2 degrees change, and the target was 1.5. Please remember, though, any of you who enjoy snorkeling or diving, that the IPCC report on the ocean and cryosphere, or the polar caps, the ocean and cryosphere report, which came out 18 months or so ago, basically said that at 2 degrees C change, we're putting at risk 90% of the world's coral reefs. Those coral reefs provide habitat and provide food source for a lot of the world's population in very densely populated, human populated areas. So there will be consequences even at 2 degrees centigrade. But if we can hold it at 2 degrees centigrade, and the very important point that Dr. Holland made, it has never been this warm in the course of human history. We have never had this much CO2 in the atmosphere in the course of human history. What is around us that took a long time to evolve? The ecosystem that we are comfortable with, that we know, that provides our food, our wheat, our bread, our vegetables, our livestock. You start changing the balance of that ecosystem with temperatures and conditions that they have not evolved in. And we're talking about a very serious set of consequences that can await us. So we have to be targeted on this. And one more pat on the back to the young people. When I watch the voices of the young people marching in Glasgow, not tolerating what the diplomats were saying, but wanting more, I say more power to you. I joined Dr. Holland, and it is up to the young people. There's something going on right now that I've been very much involved in and proud to be so. It's called the UN Decade of Ocean Science for Sustainable Development. And one of the things I've been saying since the inception of the decade, which I was able to participate in helping to guide the creation of it, I'm not going to be around for the backside of the decade. The young people are. And you need to get involved in that. You need to get involved in climate change, in climate mitigation, and helping to devise a new course, because it's the world that you're going to inherit, and you'll be in these positions to make those decisions and be guiding the direction of society. And I applaud you, because any group of folks who takes their time on a Wednesday afternoon, depending upon your time zone, or evening, to be joining us here in this conversation, you're motivated. And I want you to sustain that motivation, and you'll find great reward in it as you continue in your careers.
For us tonight, thank you so much, Dr. Holland, Mr. McLean, for your presentations and your great answers to those questions. I know I learned a lot. I was super excited to hear your presentations. And I know a lot of the students in the forum were too. So this is fantastic. Thank you both so much for your time tonight, and have a good rest of your evenings. Andrew, anything else to add?
No, I think if those two presentations and answers to those questions aren't a call to action for all of you guys, I don't know what is. So keep up the great work, and we're glad that you're all involved in the forum and attended tonight. And again, thank you to our two speakers.
Can I just add that if anyone wants my presentation, you're welcome to pass it around to everyone. And if there are some other questions you think really do need answering, just send them to me. It may take a week or two, but I will try and get to them. If you send me 1,000, it's going to take the rest of my life. But a few other questions, please send them to me, and I'll be more than happy to respond.
Will do. We've got a huge list here, so we'll pick and choose the ones that we'll send.
To the extent that I can, I'm happy to share that burden with Dr. Holland. Dr. Holland, it's been a pleasure. Thank you, sir, very much, and your work has always
Absolutely,
been inspiring.
mate. No problem at all. I'll buy you a beer next time I see you.
I look forward to that, sir. Thank you all very much.
Very much. Have a good
evening, everyone.
Cheers.
Bye.